Hello and welcome to the Chapter 3 teaser. So Chapter 3 covers data types, variables, constants, and concatenation. And in brief overview, I would have to say that variables are probably going to be one of the most important components of Chapter 3 that you really need to pay attention to. It's really important to understand what variables are, how you choose which one to use, why you choose the one you use, and how to display it, oddly enough. You would think that if I simply serial print the variable, I would get the number that I want. But in fact, you don't. Not always, anyway. So we need to know how to be able to deal with variables and be able to display them. Okay, so that being said, before I do that, I should say that if you're going to do Chapter 3, you can do it easily enough with just a teensy on a breadboard, or you can have a teensy in a motherboard, or for that matter, I think most of Chapter 3 could even be done with an Uno. So let's go ahead and get started with it. I'm going to go ahead and pull up example 1, and uncommented it, get it loading, and we'll look at example 1. So in example 1, what I've done is I've created a variable value, and it's a byte, and I've set it to equal to 255, and then I'm going to print it. Then I'm going to wait 3 seconds and increment it to 256. So you can see 255 popped up, but the 256 became 0. Alright, it's your job to figure out why that happened, okay? And don't fall into that trap, but understand why you would want to use a byte at some point. Alright, so let's look at example 2. I get it compiling. So in example 2, it's very similar, except I've changed the variable to an integer. I'm going to put it at 255, then 256, and then lastly, I'm going to increment it by 9/10, and we'll see what we get. So we get the 255, sure enough. We get a 256, and then you would expect the number 256.9, but in fact you end up with 256 again. It doesn't even round it up, okay? So this is an important point, that 256.9 is 256 in this world, all right? So once again, you need to understand the limitations of the variables that you're dealing with. So let's go ahead now and look at the next example, example 3. Let me get it compiling. In this particular case, I've created a constant integer variable value, and I've set it equal to 10, and I've also created another one, answer, which is equal to 0. And then I'm going to do a little bit of simple mathemagic and display the answer. You would expect 5 times 10 to be 50, and lo and behold, it does exactly what you thought it would do. Awesome! Alright, let's go down to the next one. I'll go ahead and uncomment that and bring that one in. So in example 4, all I've done is switch these two, right? So I've made this one equal to 0 and that one equal to 10, and you would expect it to be the same. I still have value times 5, and I still have answer, and it errored. Okay? Well, that's because I set it as a constant. So you need to understand this kind of condition and why you would use it. So let me get this commented back out again so it doesn't catch me. We're going to go to example 5. So in example 5, here we go. This one's a lot of fun. I've set an integer value equal to 9.9999, and I'm going to display it. And I get 9. That's really close to 10, but I got 9. So let's see if we can get a decimal point out of it. I'm going to just change that to a float. Okay, so now I'm going to use a float variable instead. And because floats actually, you'll find, carry decimal places just fine, and we'll see a decimal place up here. And lo and behold, 10. Well, I'm still not where I want to be. Well, that's because I have to tell it how many places I want to display. So if I put a comma 5 in here, you'll see that I'll actually be able to get the value that I'm actually looking for, because I have 5 decimal places. or 5 positions after the decimal place. And boom. Okay, now it works exactly as I had anticipated. Let's go to example 6. So in example 6, I've taken it one step further. It had to do with that concatenation thing. So here I've created a variable, introduction, and I'm going to put a string into it. Okay, a string of characters, a group of characters. And that string is now going to be the value is equal to with a space. I have set my integer value equal to 9.999, and then what I've done here is I've concatenated the string. I've taken the intro and I've added it to the string. I have to convert. Anytime that I have, see in this case, all I had was a variable. I don't need to convert the variable into a string within this string call command. But in this particular case, where I'm mixing things, mixing formats, I do. So I have to put a string in front of this. And I want to convert value into a string. And of course it gives me the answer that I didn't really want. Okay, so now let's go ahead and switch that back to that float. And you'll see that we get, you can probably predict this from the last example, what we're going to get. But I want to show you this concatenated string. And okay, so we got a 10.00 instead of a 9.999. So if I want to get those 9s, I'm going to go ahead and put in 5 placeholders. And I'm actually going to do one other thing. Let's say, for example, this was in meters. Okay, I can actually just concatenate like this. And now you can see I've added a character here. I could have actually I can write it all out so you can see that I can go ahead and make this a whole string. And what we should end up with is the value you're probably anticipating, which is going to be, hurry up, there you go, although a space probably would have been nice. Okay, so that being said, let's go to the last example, and let me pull that up. And this, if you're in our classes, this is an intensive only, so if you're non-intensive, well, you might want to watch it. This is actually really cool. This is less important than it used to be because now Arduino has updated and we can concatenate strings and we can manipulate the decimal place. Used to be you couldn't do that in the old serial.print. You had to actually create a buffer, and then you would then go ahead and put all the information in a buffer and display it. So this is what we call, or I call, tin printing, and you can see that what I've done is I've created an entire sentence, but I've substituted in, instead of that value, okay, the variable, I've made a reference to the variable that I'm going to then call upon here. And actually I don't need this. Let's try that one more time. I actually had a string in there, but I never made a call to the string. You'll see that that makes a call to a float. And if I load this up, it's going to work just fine. And lo and behold, there you go. And I will actually point out one other thing. You'll notice that I've made a call here to a variable. You don't see that variable being declared here at all. Another thing that's covered, at least introduced in Chapter 3, is the concept of a global. Okay, so if my variables are up here above setup, these are global variables. You can use them. If I declare this variable here, I can use it anywhere in the code, okay, in any function, as opposed to these local ones which are called within the function. Alright, so that being said, that kind of ends this teaser, and I wish you success in Chapter 3, and I will see you again soon.